Hello everyone, welcome back to the series of CSCA Physics Previous Year Question. In previous video, we have already covered the first 20 questions in detail, and in today's video, we are going to solve the next 10 important PYQ of December 2025 step by step. Let's get started. Question number 21. A spring oscillator undergoes a simple harmonic motion. It completes one full oscillation in 2 seconds. Its frequency is. So time period is equal to 2 seconds, and the relation between frequency and time period is frequency is equal to 1 by time period. So we will put the value of time, that is 2 seconds. So frequency will be equal to 1 by 2, that is equal to 0.5 Hz. So option A is correct. Question number 22. A sound wave with frequency f is equal to 200 Hz travel at velocity v is equal to 340 meter per second in air. Its wavelength is. So in equation, f is equal to 200 Hz and velocity is equal to 340 meter per second. Relation between frequency, velocity and wavelength is f is equal to v by lambda, where lambda is equal to v by f. So we will put the value of v, that is 340 meter per second, and frequency, that is 200 Hz. So wavelength lambda is equal to 340 divided by 200. After solving this, we will get wavelength lambda is equal to 1.7 meter. So option B is correct. Question number 23. In a vacuum, 2 point charges separated by a distance d exert a force F to each other. If one charge's magnitude is double, keeping the distance unchanged, the Coulomb force is. So Coulomb force is K into Q1 into Q2 divided by D square. So in first case, the force will become K times Q1 into Q2 divided by D square. In second condition, this charge's magnitude becomes 2 times of the previous one. So the Coulomb force will become K times 2Q1 into Q2 divided by D square. So it will become 2 times of the force. So the new force will be double of the previous one. So option C is correct. Now we will move to question number 24. If a water droplet with a zero initial velocity falls from 5-meter high eaves, excluding air resistance, the velocity at which water droplets fall to the ground is g is given as 10 meter per second square. So the initial velocity of drop is 0 and the height is 5 meter. So we have to calculate its velocity at which it reaches to the ground. So according to third equation of motion, v square minus u square is equal to 2as. So we will put the value of acceleration, that is minus g, and displacement, that is s, will be equal to minus h. So v square minus u is 0 is equal to 2gh. So velocity is equal to root of 2gh. We will put the value of g, that is 10 meter per second square, and height h is equal to 5. So after substituting this, we will get v is equal to under root of 2 into 10 into 5, which is equal to root of 100. So after solving, we will get v is equal to 10 meter per second. So option C is correct. Question number 25. The field lines of certain electric field is shown in figure. If equal point charges are placed at points A and B in this field, the relation between the forces Fa and Fb acting on these charges is. So in the figure, at point A, charge Q1 is put, and at point B, Q2 charge is put, and these two charges have the same magnitude. And we know that the region where electric fields are closer means there the fields are stronger, and the region where the electric fields are far from each other is the region of weaker field. So here region 1 is weaker field and region 2 is stronger field. And we know that force is directly proportional to electric field. So force at point B will be greater than force at point A. So option C is correct. Question number 26. Two resistors of 200 ohm and 300 ohm are connected in parallel. The total resistance is R1 is equal to 200 ohm, R2 is equal to 300 ohm. So 1 by Rp is equal to 1 by R1 plus 1 by R2. So we will put the value of R1 and R2. 1 by Rp is equal to 1 by 200 plus 1 by 300. So we will solve this and we will get Rp is equal to 200 into 300 divided by 500. When we solve this, we will get 150 ohm. So equivalent resistance will be equal to 120 ohm. So option B is correct. Question number 27. Two resistors R1 is equal to 10 ohm and R2 is equal to 30 ohm are connected in parallel to a circuit with the voltage U is equal to 12 volt. The ratio of the current passing through resistors I1 ratio I2 is equal to. So in the figure, R1 and R2, these are the two resistors. They are connected in parallel and potential difference of 12 volt is applied. So in parallel, potential difference will be same across the two resistors where that current will be different. So I1 current is flowing through R1 and I2 current is flowing through R2. So R1 is given as 10 ohm and R2 is equal to 30 ohm. So I1 is equal to U by R1 and I2 is equal to U by R2. So I1 ratio I2 will be equal to U1 by R1 into R2 by U. So U and U get cancelled and ratio of I1 by I2 will be equal to R2 by R1. We will substitute the value of R2 that is 30 ohm and R1 that is 10 ohm. After solving this, we will get 3 by 1, that is the ratio of I1 by I2. So option D is correct. Now we will move to next question, that is 28. A certain mass of ideal gas with its temperature kept constant and pressure reduced, its volume would be. For ideal gas, we know that PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant, and T is temperature. So this nRT will become constant. So PV will be constant and V is equal to constant by P. So V will be proportional to 1 by P. That means if we decrease the pressure, the volume will get increases. So option D is correct. Question number 29. A point charge of 3 into 10 raised to power minus 29 coulomb is placed in an electric field of 6 into 10 raised to power 4 Newton Coulomb. It experiences a force of. The given quantities in the question is the charge Q is 3 into 10 raised to power minus 29 coulomb and electric field is 6 into 10 raised to power 4 Newton per coulomb. So electric field is force per unit charge. So force will become Q times electric field. We will substitute the value of charge and electric field, that is 3 into 10 raised to power minus 29, and E is equal to 6 into 10 raised to power 4. So when we solve this, we will get force is equal to 1.8 into 10 raised to power minus 24 Newton. So option D is correct. Now we will move to our last question, that is question number 29. Question number 30. The SI unit for magnetic flux density B and magnetic flux phi are respectively. We know that force is equal to ILB sine theta, that is the force experienced by conductor. So B is equal to force divided by I into L sine theta. And we know that the unit of force is Newton, unit of current is ampere, and length is measured in meter. So magnetic flux density will be equal to Newton per ampere meter, which is Tesla. So unit of magnetic flux density is Tesla, and we know that magnetic flux is number of field lines passing perpendicular through a given area, that is phi is equal to B dot A. So we have calculated the unit of B, that is Newton per ampere into meter square. So it will become Newton meter divided by ampere, which is a Weber. So option A is correct. That's all for today. If you like the video, please like, share and subscribe. Thank you.